So, sine, cosine, and tangent, right? What are these words? What part of speech are they? That's what I'm going to start with. Are they a verb? Are they an adjective? Are they a noun? Well, yeah, they're a noun. So, what is a noun, right? A noun is usually things. Things like, let's say, glasses, right? I've got a pair of glasses here. You know, they look like this. You can put them on. Pretty cool stuff. Right, what else is a noun? Let's see. What have I got in my pocket? I've got a phone here in my pocket, a smartphone. Right, you can see that's what a smartphone looks like. You might be asking, well, sine, cosine, and tangent, they're nouns. So they must be things. So what do they look like? Well, the thing is, they don't look like anything because, in fact, they're not a tangible object. So you can have a noun that's not a tangible object, you might be saying. Well, I want you to think of the word price, okay? So what's the definition of price? So you could say it's the amount of money you need to pay to acquire a product. So if I were to say, show me what a price looks like, you're going to be a bit stuck because you could show me a picture of a price tag, but that's, as a matter of fact, a price tag. That's not price. Okay, so price is a noun, but it's kind of a concept, okay? It's kind of a relationship between a product and the amount you have to pay. Now, in mathematics, we call these words functions. A function is when you have an input and an output, okay? So what does that actually mean? So, in terms of the word price, okay, the input is a product at a shop. So you go to a shop, any product at that shop that's for sale can be the input to the price function. And then the output is simply a number, right? With a unit for the currency of whatever country you're in. I'm currently in Japan, so the unit would be yen, right? So I could go to a supermarket, find an apple, put that apple into the price function, and then the output would be, let's say, 78 yen. So the reason why I brought up the word price is because sine, cosine, and tangent are used in the exact same way. So if you couldn't tell already, these words, sine, cosine, and tangent, they're nouns, they're not tangible, and they're functions. So you have an input and you have an output. Except in the input, you're no longer putting in a physical product at a store, you're putting in something else. You're putting in an angle, right? So what is an angle again, right? An angle is, something that looks like this, right? That's about 30 degrees, that's about 90 degrees, also known as a right angle. And it can go all the way to 360 degrees, which is a full rotation, right? That is an angle. So you can put any size of an angle between 0 and 360 degrees into the sine, cosine, or tangent function, as you would with putting in any product at a store into the price function. So let's say we pick a random angle, let's say 30 degrees, okay? And then you can put it into, let's say, the sine function. So you put 30 degrees into the sine function, so that becomes sine of 30 is 0.5, right? We'll get to why that's 0.5 in a little bit, but that's the same sentence structure as saying the price of Apple is 78 yen, right? The sine of 30 is 0.5. So now we're going to cover the mathematical notation of functions. So in English we would say, for instance, the price of Apple is 78 yen. Okay, so I'm just going to write that down. We're going to say price of, I'm going to use red color for the apple. Where's my red pen? There it is. Apple, okay, is, the apple is the input to the price function. And then we have 78 yen. Right, so that is the function written down in English, right? So we can see this part here, this is the name of the function, And then this here, this is the input. And then this here is the output. And in maths, we write this in a slightly different way. So we start off the same way with naming the function. So we would say price. But now instead of putting of, we use brackets. Okay, so we're going to open our bracket here. This is the same thing as saying of. And then we're going to close the brackets here. Now inside the brackets goes our input. So we're going to put apple because that is our input. So we are going to put apple in the input. And then instead of saying is, we write the equal sign like so, which means the same thing. And then we have the output at the end. 78 yen. Okay, so that is the price function written in mathematical notation. So we can actually apply the same thing for sine, cosine, and tangent. Okay, the ambulance is a bit loud, isn't it? So, okay, let's get rid of this for now. Okay, so let's use the example from earlier. Okay, we had sine of, and then the input, which I will write in red. Okay, sine of 30 degrees is, okay, and now the output. Is that a helicopter? Jeez Louise. Alright. Just so much noise. I'm just going to wait for the helicopter to pass. Okay, the helicopter is gone. So we have sine of 30 degrees is, and then the output, which is 0.5. So again, we have the name of the function, and then the input, and then the output. And in mathematical notation, we would write this sentence like this. So we would start with sine, calling the function, except we usually abbreviate sine and take off the e on the end. Just makes life a little bit easier, I suppose. And then the brackets, okay? Which means of, and inside the brackets goes our input, which in this case is 30 degrees. So we have sine 30 degrees, and we tend not to put the degrees sign, just because it's assumed that the number we're putting in there is already in degrees. And then we have is written as an equal sign, and then we have the output, which is unchanged, of course. So this here is this sentence put into mathematical notation. And this is the way you're going to see sine, cosine, and tangent used. So you can do the same thing for cosine. So we can have cosine with empty brackets there, equals, and then the output. And then we can have tangent with open brackets with an equal sign there. So we can pick some input for cosine. We can say, let's pick 90. And then the output is going to be 0. And I'll get to that later, why all these values are these values. Or we can have tan of 45 degrees. And this is going to output 1. So we would read these sentences this way. So we would say sine of 30 is 0.5, and cos 90 or cos of 90 is 0. Tan of 45 is 1. Or we can skip the of and we just simply say sine 30 is 0.5, cos 90 is 0, tan 45 is 1. So that's the way you're going to hear these functions be used. Okay, so now I want to introduce you to an open function, meaning that basically we haven't picked an input for the function yet. So you would think, okay, you might write the function like this, the sine function with open brackets because we don't know what we're putting in there yet. Which makes sense, but in maths we like to put in what is known as a variable. We want to put in a letter in there, which can be anything. We tend to pick something like x, and that just means the same thing as having an empty space for the input. And x, we can say, can equal any value between 0 degrees and 360 degrees. Which means we can pick any angle between 0 degrees and 360 degrees to be x, to then put into the sine function. And oftentimes in math textbooks you would probably see, instead of x, you might see something that looks like this, and this is known as theta. It's a Greek letter, and we tend to use theta because theta is often associated with angles, and of course the input to a sine, cosine, tangent function is an angle, so we tend to use the variable theta. But don't be scared by this. This is just the same thing as saying sine of x or sine of any letter, really. We can even have something like sine of j. Okay, so before we jump into what the sine, cosine, tangent function does, I need to introduce you to this concept called a unit circle. Now I'm just looking for a stick that we can draw on the ground with. Let's have a look. I think this should work here. Okay, so I've got my stick here. I'm going to draw the x and y coordinate plane, which looks like this. You've got a straight, I just snapped my stick there, whoops. So we've got the vertical straight line, which is the y-axis, and we've got the horizontal straight line, which is the x-axis. So it looks something like that. Okay, this direction here is positive x, and up there, y becomes positive, y becomes negative as it comes down, x becomes negative as it goes to the left. So let's say this point here is 1 unit away from the center, and so is this point here, let's say, and this point, and this point. Okay, so now the unit circle is basically a circle which has the center in the center of the coordinate axis, and it has a radius of 1. So the circle I'm going to try and draw is going to go around here, go through all of the points we just drew. So there we go, and then over here, like that. So this here, this is the unit circle, okay? Every point on the circle is exactly 1 unit away. So this length here is 1, let's pick a point here. This point here is 1 unit away from the center. This point here is 1 unit away from the center. Okay, so to summarize, it's basically a circle with radius of 1 unit, which is in the center of the x and y axis. Okay, so we've made it now to the main meat of the video. This is where you're going to get a visual understanding of sine, cosine, tangent. So here we have the unit circle. So instead of explaining, I'm just going to show you. This magnet here, when it's there, it's 0 degrees. We're going to move it up, up here. When it's there, it's 90 degrees. Okay? When it's here, it's 45 degrees. And if you couldn't tell, we're talking about the angle, okay? When we draw the point from the magnet to the center, we're talking about this angle here. This angle is 45. So when this is here, that red line is on top of the blue line, so the angle is 0. The angle between the red and blue line is 0 degrees. So when it's up here, the red line is here, okay? So we're talking about the angle between this line and this line, which is of course a right angle. So when the magnet is there, that is 90 degrees. So let's move it beyond 90 degrees. Let's move it to here. Now this is 180 degrees. let's move it again 90 degrees over here. We add 90 to that. So now this is 270 degrees. Okay, let's put it in between here so that it's exactly between 90 and 180. We're talking about this angle here. Okay, this is going to be 135 degrees. So let's move this magnet over here so that we moved it an extra 30 degrees beyond 180 degrees. So now we're talking about this angle all the way around to here, which is going to be 210 degrees. Okay, so I hope you get the idea. We're starting at 0 degrees and we're going anti-clockwise, like so. And a full rotation is 360 degrees. So when we get back here, it's 360 degrees and we're back to 0 degrees. At this point, we could say this is at 360 degrees or 0 degrees. It doesn't matter. Here, 45 degrees, 90 degrees, 135 degrees. We can put it somewhere in between. We could say this is probably about 70 degrees. What we're interested in, wherever this magnet is at, okay, let's say it's here. What we're interested in is the angle, this line from the center to the magnet. Oh, that's a bit wonky. This line from the center to the magnet makes with the positive horizontal line. This line here, we're interested in that angle. So we could say that is going to be 120 degrees here. We could say that that angle is about 120 degrees. So we can say wherever this magnet is, here, that magnet is going to have an x and y coordinate. The x coordinate, of course, being how much is shifted horizontally, and the y coordinate is how much it's shifted vertically. Okay, so I'm just going to write that down. X is horizontal, y is vertical shift. Okay, so remember from earlier, this is 0 degrees. So when this magnet is at 0 degrees, okay, we can say the x coordinate, which is its horizontal shift, is 1, because remember to the right is positive, and we have y, which is its vertical shift, is 0, effectively its height. And let's move this bad boy to its 90 degrees position. So when it's at 90 degrees, okay, we have the x, which is its horizontal shift, is now at 0 because it's on the horizontal, because it's on the y-axis now. And we have y, the y coordinate, which is its vertical shift, is positive 1 because it's went up by 1 unit. So let's move it to the 180 degree position. Now we have the x coordinate is actually negative 1 because it's shifted to the left. The left and down is always negative. And remember, it's a unit circle, so the radius of the circle is 1, so it's negative 1, and y is 0 because it's on the y equals 0 line. Now if we move this here, this is 270 degrees. We have x is 0, and we have y is negative 1 because it's went down 1. So vertically it's shifted down by 1 unit. Now we can do things in between as well. For instance, here you might say, what's the coordinate of that point when the angle there is 45 degrees? So we have 45 degrees, x is, and how would you work that out? Well, I can work it out with a calculator, okay, and I have the value, which is 0.707, approximately. It keeps on going, and y equals also 0.707. So you can see why they're the same value, because when it's at 45 degrees, exactly in between this point and this point, okay, its x value, which is its horizontal shift, this length here, is equal to y, which is its vertical shift. So the red line and the black line are equal in length. So let's pick another point. Let's say here, okay, 210. So basically, we're interested in this angle all the way across here. Let's say that's 210 degrees. Now the x-coordinate, would it be negative or positive? It would be negative because it's horizontally shifted to the left of the center. So basically we're talking about this here. And that, again, I need to check with my calculator, is going to be cosine of 210 degrees, which is negative 0.866, and we have the y value, which is its vertical shift, and that's also going down from the 0 line, so we can say that that's probably going to be negative as well. So what's that going to be? That's going to be, use my calculator, sine, that's going to be negative 0.5. So we're saying that this thing has gone down by negative 0.5 units, so this should be half. And then this here has went to the left by 0.866 units. Okay, so why am I talking about the horizontal shift and the vertical shift as this magnet moves around this unit circle? Okay, what does that have to do with sine and cosine? I thought we were talking about trigonometry, triangles. Well, actually, this is sine and cosine, okay? The horizontal shift at each angle on the unit circle is the cosine of that angle. And the vertical shift, the y coordinate for any point on the unit circle, is the sine of that angle. Okay, so I'm just going to give you a few seconds to digest what I just said there. Okay, so let me explain a little bit further. So let's say this magnet is here. So it is at the point where it's 45 degrees. So this angle here is 45 degrees. And we said the x-coordinate is 0.707 and the y-coordinate is 0.707. And in this case, so we have the horizontal shift is 0.707, vertical shift is 0.707. So if we input 45, let me just erase. We have sine, and then the input 45 is going to output this value here. Sine is the vertical shift, okay? So y equals vertical shift equals sine. And the x, which we said equals the horizontal shift, is cosine. So sine of 45 is 0.707. And the cosine of 45 is also 0.707. Because it's the same thing. Sine of 45 is the same thing as saying the y-coordinate, or the vertical shift, when this magnet is at the position 45 degrees on the unit circle. So if we want to find sine of any angle, let's say 90 degrees, we place our dot, signified by our magnet, at the 90 degrees position at the input. So that is 90 degrees. And then sine is the vertical shift, and it's vertically shifted upwards by 1 unit. So sine of 90 is in fact 1. So where would sine, so let's move it to here, where the angle is 180. So we have sine 180 is 0, because its vertical shift at this point is 0. Now we can actually check this with our calculators, it's true. So we have my calculator here. Okay, let's put sine and let's place 90 degrees into sine and we get 1. And we can put sine of 180 degrees, which we said would be 0, and it is indeed 0. So where would sine be -1? Well, it would be here, right? Where it's shifted -1 units. Also, you could say it's shifted 1 unit down. So this here, the angle here would be the angle all around there, all the way to there, degrees. So we would write sine 270 is, we guessed it's going to be -1. So let's just try it in our calculator and see if it's true. Okay, sine of 270 is indeed -1. And we can do any angle, okay? We can find the vertical displacement of any point on the circumference, any angle. So we can say, I want it here, okay, where it's 70 degrees. So I want to find the vertical displacement, this length here, when it's shifted 70 degrees that way. So we can say just sine of 70 equals, and then that is going to give us the vertical component. So sine of 70 degrees is going to give us 0.9396 continuing. So we have sine of 70 is 0.9396. Okay. So that is basically all that sine is doing. You put the input in, and the output is basically the vertical shift. And cosine, on the other hand, is the same thing, but it's the horizontal shift. So if we draw in our small unit circle here once more, we have cosine, which is the horizontal of any angle. So we want to take the cosine of 0 degrees. So 0 degrees, we place this magnet at the 0 degrees position, and we look at the horizontal shift. So it's shifted 1 unit to the right. So it's going to be 1. Let's try cosine of here, 270 degrees. And that's going to be 0, right? Because it's vertically shifted, but it's horizontally, it hasn't shifted at all. So let's try another one. Let's try this one here. Cosine of 180 degrees. So it's -1 because it's shifted 1 unit to the left. And we can do in-betweens as well. We can try this here, 30 degrees. So we're interested in this angle here. Cosine of 30 degrees, and we want to find its horizontal shift. So we're talking about this length here. That length is going to be cosine 30, 0.860 approximately. 0.866. Okay, so to explain the tangent function, I'm going to be using my laptop. So here we have the unit circle. If we zoom out, we can see the vertical y-axis and the horizontal x-axis, and the unit circle right in the center of the two axes with a radius of 1 unit. So we can rotate this radius any amount of degrees. So let's rotate it to around there. Now we can let this angle there be x. So then the tangent function, tan of x, let's leave a space, and we're going to copy this into the tangent function. So tan of x equals the slope of the red line. Now the slope, also known as a gradient, is given by the formula rise over run. And in this graph, the rise is this length here, and then the run of this point here is like so. So from our previous section of the video, we know that the rise is the vertical shift, which is the y-coordinate, which is sine of x. And we know that the horizontal shift, this line here, is cos of the angle. And we said that the tangent of an angle is the slope, and the slope is its rise over run. We have a very useful formula, which is that tangent of an angle is equal to sine over cosine. So let's just take these away, and what would the tangent of the angle 0 be? So when the red line, the radius, is at 0 degrees, there is no slope. So the tangent of 0 degrees is 0. Because rise over run, there is no rise, and the run is 1, so it's 0 over 1, which is 0. What about when it's at 90 degrees? Tangent of 90 gives us an error. Why? Because let's do the rise over run. The rise, also known as sine of x, sine of 90 is 1. It's shifted 1 unit vertically upwards. But horizontally, cosine of x is 0. So we have 1 divided by 0. And you can't divide numbers by 0. It gives us an error. It's undefined. So try tangent of 90 in any calculator, it will give you some sort of error. So another interesting one to look at is tangent of 45, which is right around here. Tangent of 45, have a guess what it is. It's its rise over run. This is its rise, this is its run. Sine x over cos x, sine 45 over cos 45. It gives us 1, because in fact sine 45 equals cosine 45. In other words, the length of this line here is the same as the length of this line here when this angle here is 45. Wow, that's pretty big. Okay, so now I want to show you how everything connects. So we have this is sine of this angle, and then cosine of this angle is this line, it's horizontal shift. So I'm going to make cosine blue, and I'm going to make sine a nice green color. What we can do is we can shift this blue line all the way down. So now, what do we have?
I'm just going to highlight what we have and copy it over here. See, we have a triangle. And what kind of triangle is it? It is a right angle triangle, which is the basis of trigonometry. So now that's all I've got time for today, and I understand obviously this video isn't going to get you 100% in your next trigonometry exam, but I hope it gave you a visual understanding instead of just memorizing that sine is opposite over hypotenuse, cosine is adjacent over that, and I will be posting more videos about trigonometry as well as other mathematical concepts on my channel. So if you would like to subscribe, that would mean a lot to me. But this has been Jay. Thank you very much for watching, and I'll see you in the next video.